Alright, so we're looking at some shortcuts or patterns which will greatly help you in your efforts to solve quadratic equations. And one of the most important patterns is the difference of two squares, or the product of a sum and a difference. So here's the rule. Um, so if you've got, let me actually just write out an example. So if you got some number plus another number times that first number minus the second number, um, what that would equal is the first number squared minus the second number squared. And you can FOIL this out, and you'll see that when you FOIL it out, combine like terms, simplify it as much as possible, what you end up with is the first number squared minus the second number squared. So this is the product of a sum and a difference, and this is the difference of two squares, a square minus a square. Um, and in what this is really useful for is if you've got um, a polynomial like that, and it's part of a quadratic equation. It's not just expression like this. It's part of an equation. Um, you'll actually need to factor it into something like this so that you can solve it using a certain method. So if you can um, start with the difference of two squares or rewrite what you have so that it is a difference of two squares, then you can just expand it like this, or factor it like this, I mean, easily without causing yourself too much headache. You can just follow the pattern. So let me show you what I'm talking about. So okay, so on this lesson we're concentrating on this side of the equation, this side. Okay, we want to see things as the difference of two squares. The ultimate goal will be to then to factor it out into something that looks like this. But just identifying the difference of two squares is the first and hardest part. So I'm going to start with a relatively straightforward one, x squared minus 25. If I can rewrite this as the difference of two squares, I can factor it out like this. So x squared is already a square. Well, what am I going to do with this 25? Is there a way to look at that in a different way? Is there a way to rewrite that? Well, we could write this as x squared minus 5 squared. 5 squared is 25. So now I've got something as a number squared minus another number squared. So in this example, my a would be x, my b would be 5. A and b just stand for some number and then some other number. So then I could actually factor this out. It's a plus b, x plus 5 times a minus b, x minus 5. Alright? So this becomes that, and that becomes this. And this is important because you can use this to solve quadratic equations in a certain way, in a pretty cool way. Um, but for now, let's concentrate on just this skill. That's the hardest part. This part you just follow, it's plug and chug. You follow the pattern. It kind of does itself. This part is the hardest part. Is seeing things as the difference of two squares. All right, so let's look at this one. 4x squared minus 36. So neither one is expressed as a square. Yeah, this squared is just x squared. This 4 is not part of that. It's not being squared. And then 36, 36. So let's start with the easy side. 36 we can rewrite as 6 squared. 6 times 6 is 36. Now, what can we do here? Well, we could rewrite the 4 as 2 squared. Let's write 2 squared. So we could rewrite this as 2 squared times x squared, which means that if I've got both of these things squared, I could actually write this as 2x squared. Because if I were to start with this, 2x in parentheses squared, I would square the 2, and I would square the x. Right? So, yeah, so I could rewrite that first term as 2x squared. So now I've got a number squared minus another number squared. Make sense? All right, so let's keep going. They get harder. We've got 9x to the fourth minus 81x to the eighth. So it looks like we're gonna need to know the this rule of the power of a product, and actually we're gonna need to know powers of powers. So, for example, x squared to the third would be x to the third times sorry, no, sorry, I thought this was 2. Sorry, x squared to the third would be 2 times 3 is 6, so this would be x to the sixth. So a power raised to a power is you multiply the power. So x squared to the third would be x to the sixth. So we'll use that principle here. First, let's rewrite the 9 as 3 squared. And then what we've got here is, so x to the fourth, we could rewrite that as x x squared squared. So x squared to the power of 2 would be x to the fourth. So now I've got two things that are being squared, which means that I could write it as this: 3 times x squared, and put that power that they both have on the outside. So 3x squared squared. So now this term is written as something squared. And if I were to do it backwards, this would be 3 squared times x squared squared. X squared to the power of 2, which would be 9 times x to the fourth, which is what I start with. Okay? Alright. If this is a little confusing, that's okay. Probably this maybe get as complicated as it gets. Not quite sure. You might not get something that is this complicated, but if you do, that's fine. You can do it. So just keep in mind these exponent properties. And if you need to review the exponent properties, go review the exponent properties so you kind of have that in your back pocket. Okay, so we've rewritten this whole thing as 3x squared squared. Okay, now let's do the same sort of thing with this. So 81 we could write as 9 squared. X to the eighth we could rewrite as x to the fourth squared, because x to the fourth squared would be x to the eighth. And I've got the product of two things with that same power, so we could rewrite this as 9x to the fourth squared. Like that. So now I've got this written as some number squared minus some other number squared. And then it'd be easy to factor it into two things like this. So, okay, last one. And this, oh yeah, this will happen a lot. So I've got xy to the fourth minus 49x. Now, first thought might be, well, here we always started with rewriting, each piece of the product as a power. I can't do that. Just the y, only the y is being raised to the power of 4. So this is just x. So I could do x to the 1/2 squared like that, but that's just, there's no reason to do that. I mean, you could do that if you want. Go for it if you want to, but that gets messy unnecessarily. Okay. And in fact, don't do that because that'll trip you up later on. Yeah, I wouldn't mess with that. I'll show you that this is a better way. Okay, minus 49x. Well, if you look, these two terms share an x in common. So I could actually factor that x out and call this x times y to the fourth minus 49. Does that make sense? So in other words, if I were to write it like this and go backwards, I'd do x times y to the fourth minus x times 49. So I can factor out that x that they have in common. Now I can just concentrate on making this inside piece look like the difference of two squares. If I factor out this x, now let me just keep breaking this down, and so it looks like something like this. Yeah, so y to the fourth, I could rewrite that as y squared squared, um, and then 49, you could write that as 7 squared. So inside here is the difference of two squares, and then the whole thing is multiplied by x, and that would be good. That would help you out, when you're solving problems. Trust me. All right, so there we go. That's identifying the difference of two squares, seeing where you can kind of rearrange things, look at things from a different angle, so that you can write it as the difference of two squares, which then kind of opens up this whole new world for you, which will help later on as you solve quadratic equations.